Morning, ma'am.
Good morning, ma'am.
Good morning, ma'am.
Good morning. So last semester already I have taught you some uh, cycle related to the steam power plant. So that cycles are your Carnot cycle. Also I have discussed the Rankine cycle. The modified cycle I have discussed a little bit only. So we'll discuss in detail in this case. So all of you have the idea about the steam power plant. So here the basic components are your boiler, turbine, and your condenser. Then it is your heat pump, right? So simple prompt. So in that case, the Rankine cycle we are considering at it is a theoretical or cycle or thermodynamic cycle to evaluate the work and heat transfer in the particular components or particular process. So here the boiler is used to find out the steam to generate the steam. So the purpose of that steam purpose of that of the steam is to generate electric power in the plant, and another is to produce the same. Food manufacturing, paper mills. Mm, it's the purpose of your steam power plant. Is to generate the electric power. It is the heavy application in case of your generation of your electricity. So this steam power plant is also used in case of the industrial application to generate the steam, and that low pressure steam and low temperature steam can be utilized in the textiles, so pressing of your clothes and dyeing of the clothes. And also in food manufacturing, there we are using the drying the food. We can use this type of steam. And pepper mills, they are also to braise the peppers. And mm, um, mm, that pepper mills we are using, sugar mills and refineries, etc. In different industrial application, we can use this type of steam power plant. So based upon this, the steam power plant can be classified as, based upon your application, your steam power plant is classified as your central stations. Another one is your industrial power station, or it is the captive power stations. Okay. So central stations and captive power station, or we can say it is the industrial. It is also known as the industrial power station. So first one is your central station. So in case of your central station, the electrical energy which is produced in case of the which is produced in case of the power plant, that energy is meant for the general sale to the customers. So who want to purchase this type of electrical energy. So that is central station means whatever the energy is available, that is meant for the general state sale to the customer. Okay, so these stations are generally, it is the condensing type. So condensing type means where your exhaust steam will be discharged to the condenser instead of your atmosphere. So here condenser will use to generate the condensate. Okay, so in case of the condenser, the pressure will maintain below the atmospheric pressure, and that steam or exhaust steam is condensed. Okay, so central station means in this case whatever the energy, electrical energy will be available, so that will be used for the general sale to the customers. And here these type of stations are condensate type. Condensate type means here the exhaust steam will be not released to the directly to the atmosphere, that will be used as condensate form. In case of the that condensate will be generated by the help of the condenser. So in that condenser, the pressure will be maintained below the atmospheric pressure, and that exhaust steam will be condensed. Okay, so that is the central station. Next, what is next one is your yes, exceptions are your captive power station. Those are non-condensing type. Non-condensing means here the steam will be directly to release to the atmosphere. or it will be utilized for some general purpose. It is based upon the providing. So condensing type, no? Condensing. Here steam will be condensed. So in central power station, so large amount of steam will be adjust to the atmosphere, no, from the turbine. So that can be utilized in that stations. Yes, that to produce the maximum output. But in non-condensing type, so that exhaust steam, one is exhaust steam means that is from the turbine, no? So that exhaust steam will be utilized for certain application in their plant itself. That will be not condensed. So that is a non-condensing type. So now I'm going to discuss that one. Okay. So next one is the captive. So captive power station means it is the industrial power stations. Okay. So industrial power station means so steam will be available for the different applications. So like your in your textile industry, food manufacturers, and paper mills industry, sugar mill industry, refineries, they will have the captive power stations. Okay. So that that power station this power station will be run by okay. So this power station will be run by the manufacturing company for its own use only, and this one is the abbreviation for the output. So output is not available for the general cell. So generally these type of plants are non-condensing type. So non-condensing type means here the large quantity of steam which are in low pressure will be required for the different manufacturing operations. Okay, so one is it will generate its own electricity. The another one is the exhaust of the low pressure, low quantity, a large quantity steam with the low pressure that will be utilized for the different operations of the manufacturing companies. Okay, so in case of the non-condensing type of power plants, in this case the amount of amount of your energy energy extracted per kg of steam will be increased. Okay, so in this case the given size of your turbine will be develops the more power because the steam is again utilized for certain operations. The here the steam um, which has been condensed in case of the what directly that will be uh, the what I can say in this case the steam which has been condensed into the water in the condenser that can be directly circulated into the boilers and with the help of the pump. So in condensing steam power plant, so there will be the continuous supply of your feed water. Supply of feed water. So in this case, we do not have any cooling tower. Okay. So it will be directly given to the given from the river itself. So this is all about your captive power stations. So these are the steam power plants are divided into the different station. One is the central station, another one is the captive power stations. Okay. So now here it is the layout of your modern steam power plant. So if you are observing in this case, the red line is for the steam generation, and that steam will be utilized for the um, electricity production. So that condensate, that condensate will be formed with the exchange of the heat with the cold water. So here if you are observing the hot water from the condenser, that will be cooled in case of the cooling tower, and that cold water again it will supply to the condenser. Then that condensate will fed to the uh, your boiler by following this line. So here that line you can see that it is the low pressure feed water heater. So before that one it will be water treated. The water treatment will plant will be there, and that water will be treated to remove the any dust particles or anything will be there, that will be removed. So deaerator is present. So what is the function of the deaerator here? So it will deaerator means it will remove the dissolved gases from the feed water. So the water which is going to the boiler. Deaeration will protect the steam system from the corrosive of the gases. Okay. So dissolved gases it will reduce. Then it will be fed to the economizer with the help of your high pressure feed water heater. So in case of the economizer, there will be the exchange of heat from the flue gases to the feed water heater. So preheated water will enter to the boiler. So whatever the waste heat is available in case of the furnace of the boiler, so that will be utilized in case of the economizer. So plant efficiency can be increased by this way. So that preheated water, if we are giving to the boiler, so here whatever the heat is required to generate the steam, that will be minimized. So the fuel consumption in this case can be reduced. Okay. So then this is the um, feed water or a steam flow circuit. So generally, in case of the modern power plant, so there this layout of the modern power plant can be divided into the four circuits. Those name are okay. First circuit, first one is the Okay, so it is having the four circuit. One is your coal and ash circuit. So if you are observing in this case, it is the coal and ash circuit. This person is the coal and ash circuit. So here in this case, the coal handling and from the coal unloading to up to the coal supply to the boiler will be there. So the coal will be prepared outside of this furnace, and that as per the combustion criteria, the size will be prepared, and that cold storage will be also done in case of your handling power plant. Then there we will have the ash storage and ash handling system. So whatever the ash will be generated after the combustion in case of the furnace. So if it is the solid type, so we are using the coal. So here it is the coal. So generally, maximum thermal power station or a steam power station, those are using the your solid fuel, that is your coal. So different types of coal can be utilized as per the availability and as per the efficiency of your power plant. So here over the grate, the solid fuel will be burned, and that due to the combustion of that solid fuel, the ash will be collected at the ash pit, and that will be handled in case of the ash handling plant, and then it will be stored in ash storage location. Okay, so this whole process is known as your coal and ash circuit. So I will discuss in detail in next class, because after this I'm going to discuss the power cycles. Okay, so here it is having the coal and ash circuit. There then we are having the air and gas circuit. So air and gas circuit means it is the supply of your air in. This is the air. Okay, and there we are having the flue gas circuit. So this is whole arrangement is known as your air and gas circuit. Then we are having the feed water. So this is the feed water, right? Feed water and your steam circuit. So then we are having the cooling water circuit. So this portion is discussed as the cooling water circuit. So individual here it will have the different functions. So in next class, or after the discussion of the thermodynamic cycle or working cycle, I will discuss this circuit in detail. Okay, so just to know the different um, um, layout of your modern power plant, I have shown you this diagram. So next one is your vapor power cycle. So vapor power cycle means, already I have told you in the last semester, it will have the four different components. Vapor cycle power cycle means it is the thermodynamic cycle. So it will have the um, mm, it is the Rankine cycle. So first one is your Rankine cycle. So here we will have the different components. So first one is your, it is your boiler B. So high pressure, high temperature steam will be generated, and then steam will be utilized in case of the turbine. Okay, so in case of the turbine, that high pressure, high temperature will be expanded reversibly at reversible adiabatic expansion will be done in case of the turbine. Okay, so then that exhaust steam will be fed to the condenser. Here it is the cooling water. So it is your condenser. The name is I have given insert, that is a condenser. So in this case, the heat rejection will be there. Here it is the heat addition Q1. In this case, heat rejection will be there. That is your Q2. So heat rejection in case of the Rankine cycle is that is done at the constant pressure, right? So heat addition is also done in it is the at the constant pressure. Here it is also the constant pressure. Then there will be the feed pump. So the feed pump will be utilized to pump the low pressure and low temperature water to the boiler. So this is the working cycle for the theoretical power cycle, that is the Rankine cycle. So vapor power cycle means in this case we are using steam. So two phase handling will be there in this case. So one is the water and another one is the vapor. So here it is the two phase of working fluid will be utilized. So also I had discussed the gas power cycle. If you have remember, can you tell me what are the gas power cycle
Brayton cycle.
and only Brayton cycle? So what is Brayton cycle, Ayush? Tell me.
In
Shivam
this
Agasti.
in this gas is utilized as the fuel.
Okay.
Means if burning of gases, combustible substance produces gases which are utilized in the whole process.
Okay, Brayton cycle are generally utilized for gas turbine power plant, right? Right. Am I
Yes, ma'am.
right? Okay, so last semester also I have taught you the other gas power cycle. Can you name it?
Yes,
Shivam
I can.
Agasti, where are you? Roll number 48.
Yes, ma'am.
Tell me, tell me, what are the gas power cycles? Forgot. What are the auto cycle, diesel cycle? Dhruv Mehta,
Ma'am, ma'am, Sterling cycle,
Stirling cycle. Okay. Then,
Ericsson,
mm, the basic Otto cycle, sorry, basic gas power cycle I have told you na last semester.
auto and diesel
We have
also.
discussed Otto cycle, diesel cycle, dual cycle, right?
Yes, ma'am.
Ayush Agarwal, you are also told, yeah, a gas turbine cycle, that is the Brayton cycle. So these are the gas power cycle. So in that case, the hot air will be utilized to um, hot air or hot product of combustion will be utilized to generate the work, right? But in case of the vapor power cycle, the working fluid is the in case is in two phase system. So here the steam will be utilized to um, to get the work output. So in case of the vapor power cycle, I have discussed to you Rankine cycle, reheat cycle, regenerative cycle, and there are the other cycle also, binary vapor cycle. So here we will discuss that one. And okay, let us continue that one, Rankine cycle. So in case of this, we are having the constant pressure heat addition and heat rejection process, and here it will have the reversible adiabatic expansion process. So in this case, we will get the turbine work output. In this case, it is the pump here. work will be transferred to the working fluid, or work conjunction will be there. So here the work transfer is reversible adiabatic manner. So Rankine cycle is the theoretical cycle, or ideal cycle, we can say that. So if you have remembered that pH diagram, PV diagram, TS diagram, again I am redrawing it. So what will be the PV diagram? Actually, I'm not able to draw it perfectly. Wait again. Okay, now you tell me this one is the PV diagram, right? So this PV diagram is also known as, have you remembered pure substance? There I have told you. Pressure volume
Mollier diagram.
is
Mollier.
also known as which
Mollier
diagram?
diagram.
Mollier diagram. मार खाओगे. Okay, तो HS diagram क्या है?
HS is Mollier diagram.
Okay, HS is Mollier diagram. So PV diagram is also known as your properties diagram, है ना? Property diagram, याद है? ये property relation हो रही है ना? Pressure is the property, volume is the specific volume is the property, right? H भी है property, S भी है property, T भी है property. Forget all these things.
Ma'am, all the diagrams will be property diagram only. No?
Yes, all the diagram are the properties diagram. So what is this? Please tell me. This one is known as?
Saturated liquid line.
No, this portion. So this shape is known as?
Dome.
बोलो.
Dome shape.
Dome shape तो है. क्या है नाम उसका? बोलो.
Critical
ये हर दिन
temperature.
evaluation करूंगी. Okay, this point is known as the critical point, right? So ये क्या है? ये डोम को एक नाम दिया जाता है. क्या डोम है?
Vapor dome.
Vapor dome. Who has given the answer?
Ma'am, Ayush Agarwal.
It's okay. So what is this line? Left ये क्या है? और ये क्या है? ये line क्या है?
Saturated.
This one is the saturated liquid line, and this is
Saturated vapor.
Vapor line.
So यहाँ पे जो है what is the condition of the substance left of this? Pressure visible नहीं है?
No,
No, ma'am.
Yes, ma'am, not visible.
तुम ना ठगो मत. अब स्लाइड पर नहीं दिख रहा है. अच्छा ठीक है. Now is it visible?
Yes, ma'am. लिखते समय
Okay.
दिख रहा है.
लिखते समय दिख रहा है. अच्छा ठीक है. So ये this question क्या है? What is the condition of this substance? ये तो आपका सैचुरेटेड लिक्विड है, ये परसेंट सैचुरेटेड लिक्विड है, ये जो
Compressed liquid.
सैचुरेटेड लिक्विड
Liquid.
स्टेट है, ये कंप्रेस्ड
Liquid.
Compressed liquid.
liquid. Okay, fine. So who has given the answer? So next time what I will do, I will take the surprise test during your class. I will share the Google form. So that time I will take. So based upon that one, your TA mark will be given.
Ma'am, in how many days?
That I don't know. That depends upon. So all of you have to read every day. So next class, that is, it is on Monday. So all of you do some homework. Your home assignment is, so in our India, what are the power plants available, like your diesel power plants. Okay. So diesel power plant and thermal power plant, that is your steam power plant. These two, you take the data. What are the data required? So data are your what is the output of the plant, so कितना मेगावाट का है, और दूसरी बात है कि कहाँ कहाँ अवेलेबल है. हाइड्रो इलेक्ट्रिक पावर प्लांट का नहीं कीजिएगा, या न्यूक्लियर पावर प्लांट का नहीं, सिर्फ स्टीम पावर प्लांट और डीजल पावर प्लांट का. ठीक है, ये है आपका होमवर्क असाइनमेंट. तो ये कॉपी किसी से नहीं कीजिएगा, खुद वर्कआउट कीजिएगा और सबमिट कीजिएगा. So now I'm going to discuss, it is the PV diagram. So in case of this PV diagram, we will discuss the individual process. So first one is the boiler. So as I have already told you, in this case boiler, your so your liquid will be converted into the steam. So that steam may be it may be the wet steam, or it may be the saturated steam, or it may be the superheated steam. Okay. So in that case, that boiler, there will be the constant pressure heat addition process. That this is your steam. Let us take, it is the boiler component. Let us give the name. Here it is the 1, 2. This is turbine case. Then 2 to 3 is your condenser case. Then 3 to 4 is your pump. Then 4 to 1 is your boiler. So here it is the 4 and it is your 1. So if it is the saturated liquid, let us give the name, it is the 1. If it is the superheated, the name is your 1 dash. If it is the wet steam, it is the 1 double dash, or you can take it is the 1 dash, 1 double dash. Okay, so the output of the steam will be, it may be the wet steam, or it may be the saturated steam, or it may be the superheated steam. So if it is the wet steam, so here we will include the X. What is that X? It is the X का क्या है आयुष, क्या नाम दिया था?
Dryness
Dryness
factor.
fraction.
Dryness fraction. Very good. Dhruv and Ayush, both have given answer, I think.
Yes, ma'am.
Yes,
Okay.
ma'am.
So here here it is your reversible adiabatic expansion process. So a little bit it will be not straight in case of the PV diagram, it will be little bit like this. So let me erase this one. if it is the superheated, then expansion will be up to this. So let us draw the line here. So here it is the constant pressure heat rejection process Q2. Here it is the Q1. So wet steam means so expansion will be it will be within the wet region. Okay, so from this to this point is it is the condition of the substance will be from the saturated liquid to the saturated vapor. In between these two, that will be the mixture of liquid plus vapor. Okay, so here in this case it is the expansion is 1 to 2, in this case 1 to double dash, in this case it is the simply 2 dash. Okay, so then there will be the heat rejection, that is a constant pressure heat rejection. So that heat rejection will be up to the saturated liquid. So in this case, that point is your 3. So 3 means in this case, 3 to 4 again there will be the reversible adiabatic compression work. That compression or pumping work will be done by the that feed pump. So that is that can be so. It can be shown like this. Okay, so it is the PP diagram of your theoretical cycle, that is the Rankine cycle. So if you are observing in this case, the 3 different steam condition we have taken, and the expansion will be also shown in this case. So next one is the TS plot. So TS plot is, it is the temperature and entropy plot. It is also a property diagram. So this region is shown that the heat is added from the compressed liquid to the saturated set. So directly at saturated liquid, we are not adding the heat in case of the boiler. Okay, so that's why little bit it is up to the back side of the saturated liquid line. So this is the pumping will be done up to this region. Okay, so this is your TS plot. So TS plot in this case, if you remember, we were drawing like this. So in case of the temperature entropy plot, that this is the constant temperature line, so or constant pressure line. So in this case, that phase change will occur from this liquid to the vapor. So this is the heat addition process Q1. So if it is the saturated vapors, and then it will be taken as 1. If it is the superheated, then we were drawing like this. It is the superheated vapor, so that will be reached at the temperature, certain temperature, right? So this is one double dash. Then it is the wet steam means, so somewhat here we can take the reference, so that is the 1 dash. So then there will be the expansion. So expansion will be done as the reversible adiabatic. Reversible adiabatic means it is the isentropic process, right? So in that case, let us take this point is your 2 dash, 2 double dash. Similarly, from 1 to 2, it will be the reversible adiabatic expansion process. So that is the isentropic process, that S1 and S2 will be same. S1 double dash A is equal to the S2 double dash. Okay, so these are the reversible adiabatic expansion process, it will be done in case of your turbine. So in this case, you will get the work output. So then what we were doing, then there will be the heat rejection. So let us draw that line. So heat rejection will be at the constant pressure and constant temperature. So here it is the Q2 rejection. So this one is your 2 days. So if it is wet steam I am taking, then that will be, this will be the condition of the outlet at the turbine 2 days. Okay. So then what we were doing, then there will be the pumping work will be done. So the point is known as your 3. So this is 3, this is also 3. So here it is the reversible adiabatic compression work. So up to this we were taking. Then there will be the heat addition, continuous heat addition, that will be converted into the saturated liquid. Then it will be converted into the wet steam, or it may be the saturated steam, or it may be the superheated steam. So heat addition will be occur from point 4 to this. ये डायग्राम मैंने दिखाया था आपको टीवी प्लॉट में, ऐसे करके ऐसे करके ऐसे करके दिखाया था प्योर सब्सटेंस में, अगर आप लोग को याद है तो ठीक है. So here it is the heat addition process. 3 to 4 is the compression work. Here it is the turbine work. So this is the TS plot of the theoretical cycle, that is the Rankine cycle. So then Mollier diagram, that is the HS diagram, the enthalpy and entropy diagram, that was, let me draw this one here. ठीक है, so ये है HS diagram. So HS diagram was little bit, okay. So in this case, at different pressure, we can draw that line. So यहाँ पे pressure line कैसे था? Pressure line इस type का था. Molder diagram आपको जो मैं दिखाई थी, ठीक है. So this will be like this, okay. So it is the pressure P1. This one is the pressure P2. P1, P2. So dry saturated अगर होगा vapor, so this will be the 1 and this is the 2. Okay, ये reversible adiabatic है, तो constant entropy होगा, तो directly straight line draw किए. So if it is a superheated, then you can draw from this line. So it will be the 1 double dash, 2 dash. If it is a wet steam, so आप इसके अंदर draw करेंगे 1 dash and 2 dash, ठीक है. अब ये है आपका 4 point, sorry ये 4 नहीं होगा, थोड़ा पीछे होगा. This will be the 3. It is the 4, 1 2 3 4, okay. So ये है आपका HS plot. So here it is the heat rejection Q2, heat addition Q1, okay. So this is the properties, these are the properties diagram drawn for the Rankine cycle, theoretical cycle. So in this case, what we were doing in that case, to get the energy from the individual component, that is from the turbine, or in case of the pump, in case of the condenser in the boiler, we were applying the steady flow energy equation. Then we were finding out what is the heat transfer and work transfer from the from that process, okay. So steady flow energy equation, if we are applying, so in this case steady flow energy equation is used to find the for the ideal flow process only, steady flow operation. So in this case, we have considered that for 1 kg of fluid, so first component is your boiler. So in that case, that boiler is considered as the control volume. So in case of the boiler, that is the operation is your 4 to 1, right? 4 to 1 operation. So in this case, what will be the steady flow energy equation? So in this case, what we were doing, we are neglecting K, P, so kinetic energy, potential energy. So these are all we are neglecting. So unit mass of fluid, if you are writing the steady flow energy equation, so that will give us H4, enthalpy H4, right? ये point में. So here it will be the heat addition, heat added हो रही है. Then there will be the H1. ये क्या हो रहा है, सिर्फ हीट कंटेंट का इक्वेशन दिया गया है H4 H1 एंड Q1. यहाँ पे वर्क ट्रांसफर हो ही नहीं रहा है, हीट एडिशन हो रही है. So in case of the 4 to 1, that steady flow energy equation will be H4 plus Q1 is equal to H1. So Q1 will be how much? Q1 will be, in this case, that will be the H1 minus H4, right? So similarly for the second component, that is your turbine. So if turbine is considered as the control volume, in that case steady flow energy equation will be so turbine in this case that process is 1 to 2 process, right? 1 to 2 process हमने लिया है. So यहाँ पे वर्क आउटपुट हो रही है, ठीक है. हीट एडिशन तो हो ही नहीं रही है. अगर इसको हम काइनेटिक एनर्जी और पोटेंशियल एनर्जी नेग्लेक्ट कर रहे हैं, सो इन दैट केस दैट इक्वेशन विल बी H1 इज इक्वल टू WT प्लस H2, है ना. ये ऑलरेडी हम लोगों ने डिराइव किया था लास्ट सेमेस्टर में. So this will be turbine work will be WT is equal to your H1 minus H2. So turbine work will be the taken as difference of your H1 minus H2. Similarly for the condenser, what will be the steady flow energy equation? अब ये दोनों का बताइए, कंडेंसर का क्या होगा और पंप का क्या होगा?
Q2 equal to H2 minus H3. Condenser.
हाँ, H2 minus H3.
Okay, condenser, that is process is your 2 to 3, right? 2 to 3 process. So in this case, your Q2 heat rejection हो रही है. Q2 is nothing but it is the H2 minus H3. ये अगर कैसे आया है, confusion हो रही है, तो हम इस टाइप को ऐसे लिख सकते हैं. H2 is equal to your Q2 plus H3. Okay. So similarly for the pump, if pump is considered is control volume, so that will be
3 to 4.
process
4 minus 3.
हाँ, 4
Okay.
minus 3.
So in this case,
W2
what will be the
W work will be
बताओ?
there.
H3 equal to H4
H4
plus
minus
W. H4 minus H3.
4 minus 3.
H4
W
minus
plus H3 equal
H3.
to H4.
Okay. Okay, Bhanu Prasad, tell me your roll number.
69.
69. Shivam 48. Wahid
45. ma'am.
Yes, ma'am.
45. Mirnal
119.
119. Somil
105.
105.
5.
Ankit, you have given answer or not?
Yes, ma'am.
Okay, what is your roll number? I forgot.
112.
Use N2. Okay. So we will discuss up to this. Let me take your attendance because you are having your class at 11 o'clock. So let me finish here. So next class we will continue. Okay, roll number 1,
Present, ma'am.
2,
Present, ma'am.
3,
Present, ma'am.
4,
Present, ma'am.
5,
Present, ma'am.
6,
Present, ma'am.
7,
Present, ma'am.
8, 9,
Present, ma'am.
10,
Present, ma'am.
11,
Present, ma'am.
12, 13,
Present, ma'am.
14,
Present, ma'am.
15,
Present, ma'am.
16,
Present, ma'am.
17,
Present, ma'am.
18, 19,
Present, ma'am.
20,
Present, ma'am.
21, 22,
Present, ma'am.
23,
Present, ma'am.
24,
Present, ma'am.
25,
Present, ma'am.
26,
Present, ma'am.
27,
Present, ma'am.
28,
Present, ma'am.
29, 30,
Present, ma'am.
31,
Present, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
35,
Present, ma'am.
36,
Present, ma'am.
37,
Present,
38,
ma'am.
39,
Present, ma'am.
40,
Present, ma'am.
41,
Present, ma'am.
42,
Present, ma'am.
43, 44,
Present, ma'am.
43,
Present, ma'am.
44,
Present, ma'am.
45,
Present, ma'am.
46, 46. Okay, 46, 47s are not there. 48,
Present, ma'am.
49,
Present, ma'am.
50,
Present, ma'am.
51,
Present, ma'am.
52, 52 is also not there. 53,
Present, ma'am.
54,
Present, ma'am.
55,
Present, ma'am.
56,
Present, ma'am.
57,
Present, ma'am.
59,
Present, ma'am.
60,
Present, ma'am.
61,
Yes, ma'am.
62,
Present, ma'am.
63,
Present, ma'am.
64, 64, 65,
Present, ma'am.
66,
Present, ma'am.
68, 68, 69,
16, present, ma'am.
70,
70, present, ma'am.
71,
Present, ma'am.
72,
Present, ma'am.
73, 73, 74,
Present, ma'am.
75,
Present, ma'am.
76,
Present, ma'am.
77,
Present, ma'am.
78,
Present, ma'am.
79,
Present, ma'am.
80, 81, 82,
Present, ma'am.
84,
Present, ma'am.
85,
Present, ma'am.
86,
Present, ma'am.
87,
Yes, ma'am.
88,
Present, ma'am.
89,
Yes, ma'am.
90,
90. Yes, ma'am.
91,
Present, ma'am.
92,
Present, ma'am.
93,
Present, ma'am.
94,
Yes, ma'am.
95,
Present, ma'am.
96, 97,
Present, ma'am.
98,
Present, ma'am.
99,
Present, ma'am.
100,
Present, ma'am.
101, 101, 102,
Present, ma'am.
103,
Present, ma'am.
104,
Yes, ma'am.
105,
Present, ma'am.
106, 107,
Present, ma'am.
109,
108 present, ma'am.
108 present,
Yes, ma'am. 108.
108. Okay, 108. Okay. Okay, 108 present. Then 109,
Present, ma'am.
110, 110, 111,
Yes, ma'am.
112,
Present, ma'am.
112,
Present, ma'am.
113,
Present, ma'am.
14,
Yes, ma'am.
15,
Present, ma'am.
16,
Present, ma'am.
17.
Present, ma'am.
Are you present?
Yes, ma'am. Present, ma'am. 117.
Okay. Okay. So next roll number 118,
Present, ma'am.
119,
Present, ma'am.
120,
Present, ma'am.
121,
Present, ma'am.
122.
Present, ma'am.
Okay. Okay. So
Ma'am, roll number 21 be present here.
okay.
Ma'am,
So
roll number 8 also.
why you are late? You two are late. 21 and 8.
मैम मेरा माइक्रोफोन ब्लॉक
मैम
हो
वो
गया
थोड़ा सा स्क्रीन ये हो रहा था, ग्लिच हो रहा था, तो उसके चक्कर में माइक ऑन नहीं हुआ था उस टाइम, उसी के लिए लास्ट में बोल दी।
Okay. So all of you listen. So whatever the homework I have given to you, so all of you should submit to the CR, respective CR. So they will send to me as a zip file. Okay. Ritika, Jyoti,
Yes, ma'am.
you two have to send me. Okay. So who are other CR?
Ma'am, roll 27, Shivam Kumar. Roll 85, Bhargav Subramanyam. Roll 98, Saurav Kumar. And roll 59, Akash Kumar. Akash Ghosh.
Okay. Total 6.
Yes, ma'am.
ओके तो आप एक काम कीजिएगा, जो असाइनमेंट दी हूँ बच्चों को मना कीजिएगा कि मेल में ना सेंड करें, क्योंकि फिर मुझे डिलीट करने में दिक्कत होती है। तो आप एक काम कीजिएगा, आप लोगों को वो सबमिट करेंगे और आप मुझे शेयर कर दीजिएगा, ठीक है?
Okay, ma'am.
ओके,
Okay, ma'am.
थैंक यू, थैंक यू।
Ma'am,
Oh,
ma'am, excuse me.
बोलो।
Ma'am, what exactly we have to do in that, ma'am? Ma'am, just
Okay, in that assignment, so in India, you will have the thermal power plant light. So,
yes, ma'am.
And you will have some diesel power plant. So
Yes,
you
ma'am.
have to search thermal power plant, what are the thermal power plants available and where it is available and what is the power output. Okay.
Okay,
So
okay, ma'am.
location and the power output you have to mention, and diesel power plant also you have to mention the where it is located and what is the output. Okay.
Okay, ma'am.
And
Okay.
also what are the fuels if it is available, more information if it is available, that one also you have to include. Okay.
Okay, ma'am.
Okay, you should know what are the diesel power plant available in India.
Yes,
So
ma'am.
that's why
मैम
I've given you this.
मैम बस
Okay.
नेम रिटर्न करना है ना उनका।
हाँ, नाम रिटर्न करना है और
मैम हैंड
उसमें
रिटन
एक्सेल शीट में बना
हैंड
सकते हैं क्या?
रिटन। हाँ जी,
हैंड रिटन
हाँ हैंड
एक्सेल शीट में
रिटन
नहीं बना सकते?
नहीं बना सकते एक्सेल शीट में।
ओके मैम।
हाँ,
मैम वर्ड लिमिट
वर्ड लिमिट कुछ भी नहीं है। जो ज्यादा इंफॉर्मेशन शेयर करेगा उसको ज्यादा नॉलेज रहेगी। आपके लिए ही दे रही हूँ, हाँ, मेरे लिए नहीं। ओके, थैंक यू ऑल। Classes will be taken from 9:30 to 10:30. So I have scheduled it like that. For next class onward, I'll take as per the time. My health is not okay, so that's why I used to manage. Okay.
Thank you.
Thank you all.
Thank you.
Okay. Thank you.
Ma'am.
Thank you, ma'am.